ConsistNet, enforcing 3D consistency for multi-view images diffusion. Recent advances in the latent diffusion models, LDM, for image generation have brought about remarkable success in generating high-quality images with compelling details. However, when applied to generate multiple view images of the same object, vanilla LDMs are unable to ensure the 3D consistencies among the generated multiple images. This is primarily due to the lack of mechanisms to enforce such 3D consistency information among the images taken from different viewpoints. A recent work, 0123, stands out as a promising approach for this purpose. It leverages the power of clip image embedding combined with camera embedding to produce semantically coherent images that are also viewpoint aware. However, such semantic multi-view consistent heuristics are rather weak, in the sense that the multiple view images generated by 0123 do not necessarily adhere to any shared 3D structure. Given a single image of a 3D object, this paper proposes a novel method named ConsistNet. It can generate multiple images of the same object, as if they are captured from different viewpoints, while the 3D consistencies among those multiple generated images are effectively exploited. The ConsistNet is designed to be lightweight and efficient, which can generate 16 multi-view consistent images in just 11 seconds. At the core of our method is an add-on block to pre-trained LDMs, the ConsistNet block. It exchanges information between parallel LDMs running at different viewpoints based on underlying multi-view geometry principles. For generating multi-view images using LDMs such as 0123, the LDM pipeline runs independently in parallel and cannot have information over each other. Our proposed ConsistNet blocks can be plugged into these parallel LDM pipelines, interconnect them, and enforce 3D consistency. The ConsistNet block comprises two submodules: a view aggregation module that unprojects multi-view features into global 3D volumes and infer consistency, and array aggregation module that samples and aggregate 3D consistent features back to each view to enforce consistency. In the view aggregation module, given latent feature maps obtained in different viewpoint, we start by unprojecting every feature map onto a 3D volume in unified world coordinates. This yields a 3D volume for every viewpoint. We then use self-attention and 3D convolutions to implement a view aggregation network. All 3D volumes are voxel-aligned and are attended to each other by applying a multi-headed self-attention layer in the n-views dimension. We further process the volume with a few layers of 3D convolution. In the ray aggregation module, we first warp the world volumes back to its corresponding camera frustum by uniformly sample depth along the viewing ray of each pixel between minimum and maximum depth. Then we use trilinear interpolation to fetch the feature and append the warped volume with its camera depth encoding for depth-wise attention. The warped volume is then projected to a 2D map by aggregating it along the depth dimension. We implement this projection as the ray aggregation network by a cross-attention layer. We instantiate several parallel pre-trained 0123 XL models, with each model dedicated to a specific viewpoint. Without the ConsistNet block, these diffusion processes would operate independently of each other, lacking the 3D consistency between shared views. To introduce 3D consistency, we insert a ConsistNet block to each decoder layer of the UNet, therefore allowing the feature maps to be mutually attended in a coarse-to-fine manner. On the Google Scanned Objects dataset, our model largely outperforms all existing works and concurrent work SyncDreamer on elevation 0 and 15. On elevation 30, our model performs comparably to SyncDreamer. Comparing with our base model 0123XL, plugging in our module improves its generation quality on all elevation angles. Here are some qualitative results on Google Scanned Objects dataset. Our ConsistNet can effectively improve view consistency of the generated multi-view images when using 0123XL as backbone. Here are some results using Internet images as inputs. Our model can generalize well to input images from various sources. Our code will be released soon, thank you.